Welcome to Dam Engineering channel. In this video, we will learn the different types of gates or hydro-mechanical components used in dams. If we see here, we can see spillway and powerhouse. Spillway is used for releasing the flood or excess water. Powerhouse will be generating the electricity. Both these require regulation of water. This will be achieved by gates. The powerhouse is dam toe powerhouse. The dam toe powerhouse in detail looks like this. Water enters from reservoir through intake, generates power and goes to downstream. We can see here intake gates. To operate these gates we have intake gate hoist. Further, after the power generation, we can see draft tube. Accordingly, draft tube gates, and for operating them, draft tube crane. Like this we will further see the requirement of gates in hydropower. This is general layout of hydropower scheme. Water is diverted through intakes to powerhouse. Headrace tunnel, surge shaft, pressure shaft, penstocks are intermediate components. We can see the gates for each component here. For dam, we can have spillway gates. Intakes will be having intake gates. Likewise, surge shaft gates, draft tube gates and tailrace gates. The purpose of so many gates is to isolate each component whenever any maintenance and also for regulation. We have valves also. These are generally butterfly or spherical type in the conduits for power components. Whereas in dams, we have fixed cone valves for releasing the water. As already explained, for different components we have different gates. For canals and navigation locks also we require gates. Basic difference of gates are on the shape. These are radial gates, vertical gates. Further, vertical gates are divided into two. Sliding gates, roller gates. Roller gates will be having wheels. Other type of gates are flap gates and valves. Most of the places we will see vertical gates. While lifting the gates, to avoid friction, wheels or rollers are preferred. Based on purpose also we can differentiate. Gates are used for regulation of water. When these gates are to be repaired, there should be some adequate provision. For this purpose extra gates are provided. These are called as stop logs or emergency gates. Further, there are maintenance gates which are used for maintaining the structures. Draft tube gates are always in open condition. They do not have extra provision in terms of stop logs, so these come under maintenance gates. Whenever powerhouse maintenance is required, they will be lowered to isolate the powerhouse for repairs. Most of the times, gates are fabricated in pieces. They are assembled at the site due to size constraints of plates and so on. Generally around 3 meters height pieces come as single piece. While lifting and placing, these are placed in pieces at the positions. Sometimes, there is requirement of having a single gate instead of pieces. These are called bulkhead gate. That means all the pieces are joined together. Let us say 3 pieces of 3 meters are joined together. So overall it acts as one piece. The other criteria is lifting mechanism. Simple form is rope drum mechanism. Using motors and ropes, gates are operated. The other type is hydraulically operated lifting mechanism. In small gates, we can have manual or screw type gate lifting mechanism. Further, based on the operation of lifting or lowering of gates, they are classified as balanced or unbalanced. Balanced means both sides of the gates are having water to have same pressure on either side. Here, we can see flap gates. These are generally for low head and low discharges. They will move in the direction of water to pass the flow. Gates are generally heavy weight equipment. Lifting components shall also be heavy and withstand these loads. Gantry cranes serves this purpose. These gantries are used for moving purpose to operate gates at different spillway or fixed type. Valves are really useful for their design and operation. In powerhouses, in main inlet valve, we can have spherical or butterfly valves. Further, to release excess water with upgraded technology, we can have fixed cone valve. These are capable of discharging the water without any structural requirement of energy dissipation.